Now, students, we will talk about the application of confidence interval for the difference between two population mean for large sample. So, I'm now first going to derive the formula and then we will start solving or answering the question. Now, this is the Z formula that we are given, and we did discuss the application of this formula in the previous lecture. Now, whenever we would like to construct a confidence interval formula, so confidence interval formula we set for population parameter, and over here the difference between population means is basically the population parameter we need to keep in the center. And to introduce the lower and upper bounds, we need to apply plus and minus signs with z, and we need to denote the probability of alpha by 2 that are representing, that is representing basically the area below the lower bound and area above the upper bound under the distribution of 1 minus alpha percent middle area under the curve. Now, what we can do, we need to multiply these two, and first of all we need to keep, better if I would write down the formula here in a bigger space that we have got here on this part. So we keep the population mean or population parameter in the center. We start our formula with the corresponding sample statistic, and this is a sample statistic in this application. And then minus sign on the lower bound, plus sign on the upper bound, with the sampling distribution that we are using, or which is z here, z alpha by 2, multiplied by sigma 1 square divided by n1 plus sigma 2 square divided by n2. Same here, z alpha by 2 times sigma 1 square divided by n1 plus sigma 2 square divided by n2. Now to apply use this formula, what I have done, I have taken the two examples that we discussed in the class. 10.2 is the question number that we did discuss, and 10.6 as well. So question number 10.2 was about the two groups who have been graduated in two different disciplines, accounting and liberal arts, and the sample size taken from accounting graduates was 32 and taken from liberal arts graduates group is 35. They have asked them about their annual starting salaries, at what salary they have started their first job, in fact, and this is in annual, and this is mentioned in thousands of dollars. So if 27.74 is the mean value, sample mean value for the first group of 32 graduates, it does indicate $27,740. Similarly, x2 bar value, which is 25.51, is representing $25,510 of mean salary. Similarly, sigma 1 is given as 1.73, it does indicate $1,730, and the standard deviation of the population for the group 2, which is liberal arts graduate, has a higher or greater value for the standard deviation. It is mentioned as 1.82, that is representing $1,820. Now what we do, we substitute the values in their places, and I am now writing down this formula in a consolidated way that you can also write down, and that you can find out in the formula sheet this formula in the same way or with the same structure, where in the specification of the formula given in the formula sheet the terms that you are estimating or the population parameters that you are estimating are completely missing. You should have an idea, and that idea you can get from the structure of the starting term of the CI formula. Since x1 bar minus x2 bar is the structure that the formula is starting with, therefore this entire confidence interval will estimate the difference between these two corresponding population parameters, mu1 and mu2. Now I am substituting the values 27.74, take away 25.51 as the differences between the two sample mean values. And let's assume that we are asked to construct 95% CI for mu1 minus mu2. Then the z value corresponding to 95% CI is z with the subscript 0.025. That gives us the z value of 1.96. So we substitute 1.96 here, and again I would highlight the common error made by the student that you are not supposed to do in the exam, that is missing out the square that is to be applied on sigma 1 value. So don't forget to raise 1.732 square and 1.822 square. Now what we do, we will work out these values first. 1.73 squared divided by 32 plus 1.82 squared divided by 35. Working out the answer, take the square root of the answer. That's 0.43378. Multiply this by 1.96 would give you 0.85 as a factor to be added or subtracted from the mean differences. Now the mean differences are 27.74 take away 25.51 gives you 2.23. Now we can split this confidence interval and we will write down the lower bound and then the upper bound. The 2.23 take away 0.85 gives you 1.38 that we can write down as $1,380, 1,380, because the data are in thousands of dollars. That is something mentioned in the question already. And that's 3.08 that we can write down as $3,080. Now how can we interpret this answer? We need to look at the size of both the bounds of the confidence interval necessarily, because we are looking for the differences between the two population means. Now we can interpret this answer as we can be 95% confident that the difference between the mean annual starting salaries of accounting graduates and liberal arts graduates is exceeding $1,380 and less than $3,080. So this is how we can interpret the answer. Now, additionally, if in the question we are asked for whether we can draw this conclusion that the accounting graduates are getting higher salaries on the average as compared to liberal arts. So we have to look for this purpose. We have to look at the signs of the CI. Both the bounds should be coming up with the same sign. If we look at the signs, both lower and upper bounds are giving us positive values as the answers. And positive value we get when we go for the difference and we end up with a positive sign, it does indicate that mu1 is greater than mu2 and mu1 is representing the mean value or mean annual starting salaries of accounting graduates, whereas mu2 is representing mean annual starting salaries of liberal arts graduates. Therefore, we can further draw this conclusion on the basis of our findings on the lower and upper bounds of CI are clearly indicating that accounting graduates on the average are getting higher salaries as compared to liberal arts graduates. So this is how we can answer this question. Now moving to question number 10.6, which is regarding the two different dieting programs. The first one is dieting with exercise, and second one is our second group is indicating the people who dieted only. And their mean weight losses are provided as 16.8 for the first group and 17.8 for the second group respectively. With the standard deviation, sample standard deviations this time we are given here. You can take notice of that. And 3.5 pounds is the standard deviation of the mean of the weight loss by the first group, and standard deviation is 5.2 pounds for the weight loss of the second group. Now, I would write down the formula because there is a slight change in the formula. Instead of population variances, we need to indicate sample variances. Now, substituting the values 16.8 and 17.1. Let's assume that this time I am asking you to construct 90% CI for the difference between the mean weight loss by the two groups. So Z value has a subscript 0.05 for 90% CI, and that's 1.645 is the value. So 1.645, and again don't forget to raise standard deviations to square. Now we will work out the answers. 3.5 squared divided by 37 plus 5.2 squared divided by 36. Then we take square root of the answer, that is coming up as 1.04. Multiply this by 1.645, which is the Z value corresponding to 90% CI. It gives us 1.711 or 1.71. We can write down it as 16.8 take away 17.1 gives us the answer of minus 0.3. So minus 0.3 and minus 1.71 gives us a lower bound value of minus 2.01, and minus 0.3 plus 1.71 would give us 1.41 as the upper bound. Now, if we look at the signs of both the lower and upper bounds, the signs are in disagreement because the lower bound has negative sign, whereas upper bound value comes up as positive value. So when we interpret the answers for the confidence interval in such a situation where lower bound comes up negative and upper bound comes up positive, we interpret the answers after dropping the sign in absolute terms. So if we take or consider these two answers or values in absolute terms, that is ignoring the negative sign, so 1.41 is the lower extent of difference, whereas 2.01 is the higher or greater extent of difference between the two mean values, and we interpret it accordingly. We can interpret these two answers as we can be 90% confident that the difference between the mean weight loss of the two groups is exceeding 1.41 pounds but less than 2.01 pounds. Furthermore, similar to the previous question, if we are asked to make comment on the relative effectiveness of the program, whether program 1, in which people have followed dieting with exercise, and in the group 2 all dieted only, then if there is a difference between the mean weight loss, so for the difference we again have to look at the sign, and both the signs should be in agreement. Now if we look at lower bound, lower bound is coming up with a negative sign. That indicates that group 1 and group 2 difference is negative. If this is the situation, then we can draw this conclusion that the mean weight loss of the first group is less than that of the second. But if we consider the upper bound is coming up positive, and positive values we indicate in this way. So if we move this mu2 on the right hand side, so these two findings we can see are not in agreement to each other, rather disagreement is clearly indicated. Lower bound is saying that program first is less effective because mu1 is less than mu2. So mean weight loss on the basis of first writing program is less than that of second. The upper bound is telling us a different thing. It is saying that the first program is more effective because mu1 is greater than mu2, it is indicating. So first program is more effective as compared to second, and these two findings are in contradiction with each other. Therefore, we can't say any such thing that whether program 1 is effective or program 2 is effective. This is how we do it. That's the end of large sample based CI lecture.